our beautiful headquarters in Asch, Lucerne. Hello, my name is Dennis Hintermann. I'm responsible for the corporate marketing.
Hello, my name is Fernando Marcos. I'm responsible for the product management.
Hello, my name is Kevin Domancic and I'm responsible for the customer application engineering.
We are glad that you join us today. And now welcome on stage our sales director, Jörg Schüppach.
Thank you, Denise. A good day to you, and thank you so much that you spend your time with us today. I don't know about you, but I'm really fed up with masks and with digital meetings. I rather would be with you face to face, coffee cup to coffee cup, and talk about the market, your needs, and how we can help you. Now, this is not possible, so we do our best to give you a good show for the next 45 minutes. And I hope, or my goal is, that at the end, you will get up, walk away and say, that was good. New ideas, was interesting what I heard, and you can take something with you back home or back in your office. See, you are in your office, so. All right, our story will start with the electronic market and the electronic trends in the future. In the next 10 years, 15 years, there will be a lot of changes. The electronic on the technology trend in the moment is going pretty wild. A lot of things have already started and they will evolve. Now, for example, big data, right? We will have to store humongous amount of data and we have to really speed up our transmission. Personal, most probably what we will see and feel. Already today, a lot of people have wearable watches, have other gadgets on their body, but it will be much more. We are working in the moment for a medical project where you actually will implant the electronic in your body and keep it in there. And also for the gadgets. But all these products have a very fast market introduction time. They will actually be not very long. Gadgets maybe have a usable time of 9 months. And then they will be exchanged. So this will have an influence of our production in the future. Automation, car industry is by far the largest electronic consumer in the world. In the future, we will have electronic cars. It already starts. We will have new cockpits with completely new features, how you actually touch and feel your car, as well as you have driving without somebody on the steering wheel. Lost the word. You just realized it. And you know, all this will change. Also energy efficiency, batteries, battery storage, energy transmission. A lot of this will change and will improve. And we need electronics and technology. Now, why do I tell you that on a subject like this? Basically, it will influence how production will go. In the future, we will have even a higher mix, even a faster time to market, shorter batches. NPI turnaround will be much, much faster as what we know today. So it will be a big challenge for all of us. So what we will see is actually NPI innovation speed. We will have to speed up again. I got into this market, I can't remember, in the 90s. When I think about the 90s speed we had to today, right, with bringing new products onto the market, incredible. And it will go even faster. And all of that the consequences will be that we will have high-speed lines, no question, but they will not grow much as a segment. But what will grow tremendously in the next 10 years will be for sure smaller lot sizes, changeover, material management, Industry 4.0, everything is integrated, and efficiency. So the trend is smaller lot sizes of production as of today and much faster time to market. Now, when you look at this, production trends, basically we have to cope with it. How can you cope with this? production changeover is a big thing. I'm going around in this world and looking on going into production, and a lot of time the machines are standing still or the lines. It's mostly because of changeover, material problems, etc. Reduce process difficulty. Now today we still do our things by hand, dispensing, etc. In the future that will not be possible anymore. Combine processes together, integration of flexible processes, solve unexpected things. That means in your production something is happening that you can react much faster as of today, and also be ready for future technology which will hit you. So, partial product solution of all of this can be dispensing. Dispensing is a part of the solution for this new trend, and we want to talk about that today. What does dispensing bring you in a combination with other machines? Now, on Essemtec, we are actually handling different divisions. One is a pick and place, one is dispensing, where we mostly are working with very large companies, and of course, storage. Material management, smart material management is a very big issue of today. But today we want to talk about something in combination. The pick and place and dispensing combined together, and what it can do for you. We called this concept, this solution, archerfish. I don't know if you know the archerfish. I didn't know the archerfish 6 months ago, but it's a very extremely cool fish, which is actually shooting a jet into trees, into bushes to hit down, you know, little animals, little spiders, etc. They fell on the ground for eating. Now this looks very simple when you saw it on the video, but what this fish has to do, that he gets the accuracy, everything is incredible. And this inspired us for our jet dispensers. So the archerfish is basically the multifunctional center. Multifunctional means it's an all-in-one solution. You mean processes are combined together. Processors are combined in all our machines. So solder jetting, glue jetting, pick and place, underfill processes, whatsoever, you combine in one machine, or when the speed will be an issue, you take it apart, but always on the same platform machines. Now we have a look here. Basically, we are working with 5 valves, 4 different platforms, which are technology-wise the same, so that we can do any combination, that we can do endless tasks and endless processes. And it's really endless. We have maybe in the last 6, 7, 8 months have worked at least on 25 different processes with this tooling, because it's all a question of adaptation. So what can we do? We are basically having 2 jet valves. One would be for solder and one would be for glue. And then we have 3 dispensing valves. One would be a screw, one is a voluma dispenser, and one is a time pressure, which we are not using much. And what we are covered for that is underfill, globe topping, solder the complete SMD spectrum, etc., etc. And we combine that together with a pick and place. Now, question is, where is that used? It's used actually on the whole spectrum of production. We can start with, for example, a simple NPI line, one machine with a jetter valve for solder jet printing, and the pick and place, so all in one unit, and, for example, a vapor phase besides it. Of course, this is not fast, but it's highly flexible what you can do. And what we also can do, that actually an NPI facility can change the valve and use the same machine for other applications they have to do. Or we have already a little bit more speed. We have a pick and place, in front of it a pick and place together combined with a jetter. Also there, no printer anymore, all in one. Or on a mid-range, speed is higher, you have mid-range machine, and in front of it you have a jet machine. You see that on the bottom. On the bottom, basically, that's a high-speed line. What we do a lot, we have, I think it's a Fuji NXP in the back, and in front of the Fuji, you see our dispense module. In this case, I believe it's in Hungary. It's glue application. And the very big thing on this dispensing are specialty. We are not only selling these machines to the electronic market, we're also selling to medical, non-electronic, and to other applications which are outside of the electronic market. About specialty, I will talk a little bit later at the end of the session, where I give you one example. Now, this is basically a head configuration. The Puma machine we will show you today has 3 positions. They can be freely set with dispensing or pick and place heads. So in the front, in the top, you have a typical NPI machine, meaning in the left you have a glue jetter, right you have a solder jet printing head, and in the middle you have 2 pick and place needles. And on the very bottom, you have basically a high-speed jet dispenser with 3 different processes on the same machine. So this machine will be integrated typical in a high-speed machine. Good. So to wrap it up, the first part, you get an empty board, you jet it with solder, you jet it with glue where you need it, hard to see, you pick and place, and your product is basically ready to go into the solder process, to the oven. Great. So we would like to go live to the machine and give it over to Kevin. Kevin will now show us on the machine live the different processes and what you can do with it.
Thanks, Jörg. So this is our Puma, and our Puma over here is equipped with two valves. This is equipped with 2 valves. How Jörg was explaining clearly is because that we are going to have 2 different processes. We are going to have a solder process and a dispensing process with glue. So now you can see that the Puma is doing some test dots before we start, measuring the dots and go on action. So right now we have to dispense some small dots and big dots. And the settings that I have over here, it's only for small dot basically, but inside this PCB, what we have over here, we have different kinds of pads, where in this different kind of pads, we need to shoot more dots to simulate the printing process. So we need to put more volume. So that's why, especially for the solar panel, I will explain later what we are going to place, that on the solar panel we need more volume on this particular pad. So now it's dispensing on the big pads right now. It goes on the 0.5 pitch connector. Now after the 0.5 pitch it will jump and do the epoxy. Now we'll pick and place the 01005. So we are placing on the 01005. This is the smallest component right now, it's in the market. And as you can see, it's placing them quite nice, the machine. Now we'll place the 0201s. After the 0201s, we will place the LED and then later on the solar panel. So this is one connector, second connector, LED and the solar panel. So what we have done over here. So here what we have produced. This is a keychain which we already produced. So here it's the solar panel, where over here we have 01005s. Then there is the LED, which is powered obviously by the solar panel, a connector of 0.5 pitch and a connector of 0.4 pitch. So here you can see that the components are being placed inside our 0.5 pitch, which are here, and 0201s and 01005s, they are over here. So that was we have placed so far. Now let's show only, because the main showing is on the Archer fish, which is our DST valve. Let's show and dispense only with the dispenser, and later on we will check it under the microscope, because the camera over here with the web camera might be it's not visible as good as when we go on a special microscope. So now let's just load for dispensing only. Let's take this one, and yes. So the machine will do eye points measurements. Once again, he will do a process check before we start. This is the process check. It depends on the end user, so he can switch it on or off. For us, since we're doing a test and showing a test, we're showing that the machine can do a process check as well. This will ensure your quality later on, that your quality will be good as well. So we are dispensing on the big pads. Soon followed by the small pads. So you see the two processes integrated together. As soon as the DST has been finished, immediately the glue took over to finalize the glue underneath. So when we place big components, it will be attached properly to the PCB. So let's unload our PCB, and we will take it on our microscope to see what we have done so far. So now we go on our microscope. We adjust the angle. So here, oh yes, we have the dots which are here, what we have produced so far. Let's focus a little bit. So these are the dots. Right, nice. I'd like, yes, this is just to show you on the big pads, what we have done on the big pads. As you can see on the big pads, we did a lot of dots close to each other. So like this, we can fill up a big pad much better. Now we go back. Over here, so let's increase the zoom a bit. Let's take a 3D image. Okay. Yes, nice. So, as you can see here, it's a 3D image of what we have just dispensed. This is around 2 to 3 nanoliters of volume over here. And one has to take in consideration that not only dot size is important, it's important as well the volume. The volume is very important, because keep in mind that once the solder goes inside an oven, the flux will be evaporated. So one has to keep in mind that just the volume is very, very important to our process. But here we are showing, which is quite nice process here, nice dot, that we had a very nice dots. And yeah, so let's continue on the machine. So see more capabilities of the machine, actually, what we can do. So And the nice of it, the one that we have done, I don't know whether you can see it, but the LED, it's already powering on over here. I don't know whether you are able to see it because there's less light because we're having spotlights, but it's powering on, which is good. It means our process is quite nice. So, coming back to my machine. Jörg was explaining clearly as well. Yeah, what we can do more with our machine. So, just to show you as well what we can do, we have the Gerber import. What we can do with the Gerber import. The Gerber import today is being most commonly because most of the customers, they are getting files coming with only dispensing processes, where we have introduced as well our Gerber import directly on the machine. So once the customer will have the file, we can just import it on our machine. So I will show how easy it is to import a Gerber file and transfer it to a recipe that later on we can run it on production. So let's see how we can do it. So imagine we have a USB or it's on the network, the machine. We have a file. We just load the file on the machine. Now one has to consider as well that we have various layers. On a Gerber import, we have various layers that one has to think which layer needs to go. Normally we will take the top layer. So voila, here it comes. This is our Gerber import and we have the top layer. Some layers can be defined from here. There will be other different layers. So let's select what we need. So let's assume we will take, because this is our region of interest, and we enable them. Now, as soon as I enable them, it means that later on we just need to group them. So as you can see here, we entered in another menu where we are going to group right now different pet sizes. So for the machine it will be easier to calculate what kind of dot he needs to put inside. So once I will tell them select all, and I will say group shapes. And group shapes, big shapes, they go together, and small shapes, they go together. Then it will be easier for us later on for the filling. So what remained now? Now it remained that we have to fill those shapes. So I will select all the shapes, and I just tell fill shapes. Sorry. Wow, good. So now as you can see, the system has filled my shapes, my pads, accordingly. So it tries to fill up as much as volume, how much we gave it, to fill the medium needed. So as you can see, for example, a bigger pad needs more volume. So it needs more dots inside it. Obviously, we can do over there to make it even more faster. Instead of having more dots here, we can have another DST with a larger dot size, and like this we can dispense less dots for our application. But let's go now and I will explain how easy it is to change from a 200 micron dot to a 500 micron dot, for example. So when you have something like this, so this is the Gerber import where we have done so far. And once I just press the save as recipe, then it's ready where we can start our recipe. So Jörg, if you can pass me the, oh, thank you. So as I was explaining, just we bring the machine off. So this is the DST, what we have said. It's easy to change the fluidic. You remember before I told you that when you have a big dot or a small dot, you cannot run them together. What you have to do is that sometimes you need to change the fluidic part. It depends. This one can, for example, it can take a dot from 200 to 400 micron. But then if you need a 500 to 700 micron dot, you need a different fluidic system. And this is all what you need. And it's much easy. It's very easy. For example, this is to change to a fluidic to a 500 micron dot. So it's easy. No tools required. So we just take the medium and it's out. Everything is on quick release, so it's on special bayonet. Put the new one in and it's done. All you need to do, of course, we have changed the fluidic. All we need to do is that we need to calibrate the Z height, and then we just do a dot over here, which is everything done automatically. we do a dot over here, where with the crosshair of the camera, we align accordingly the dot. We will show it later on as well. So let's go back now and, yeah, change back to our fluidic system. Might be I need to change back. How easy? Pipe out, fluidic out, take the other fluidic, plug in, and ready. Now, some people would tell me, oh, but you need to clean it. Yes, you need to clean it, it's true. But don't worry, you don't need to clean a lot of parts. This is the only part that you need to clean, actually. And here I prepared as well for you some parts which you need to clean. So, as you can see over here, with just a simple spanner, these are the parts that we need to clean. So, this one, we don't need to clean it, actually. But these are the parts that we need to clean. It's very easy to dismantle, very easy to clean, because the ports are not so small as well, and very easy to handle it, and to mount everything back. So I will pass these a little bit to Jörg first. Now, let's show you, yes, the capability of the, thanks Jörg, the capability of our machine, what we can do with our machine. So, as Jörg was explaining, the machine can handle various kinds of valves. And the valves are easily to be replaced. I will show later on how to replace a valve. For example, this is a time pressure valve. A time pressure where you can mount on every axis on which you want. Then we have this one. This one is the high volume valve, where this is good for somebody wants to do. Keep in mind, we are not only in the electronics industry. Some customers, they would have a gasket to seal or underfill or whatever. So this one is for high volume to go sort of a gasket. Then we have here our, this one I love it actually because it's fast. You saw it in action. This one is the one over here. This handles a lot the glue. Very good, and it's very, very fast. So it's a jet valve as well. And the one but not least, that one, I like it. I personally like it. Why do I like it? Because it's flexible. Okay, the speed is not as the DST or the glue valve, but it's very, very flexible. And this is the micro screw valve, our micro screw valve. And some customers, they are afraid of the micro screw valve. But I will tell you that you don't need to be afraid, especially on the cleaning, because the cleaning part of our micro screw valve is just only this small part here. And as you can see, all the other, there's no need to clean, which is nice. So let's mount it back, and we try to mount it on the machine. So to show you how easy to fix a micro screw valve instead of another typical valve. So let's put this one back. Now, let's take this one. We were going to remove our DST valve. So we take only the plugs out. And connectors are quick release. So, as you can see, the DST is out. Can you hold it for me? Now we will plug our micro screw valve in. And it's ready for action. Once again, it's ready for action. Okay, we need to calibrate the Z height. We need to calibrate the dot position with our crosshair. But as you can see, it's ready for action. Now, let's put it back and see the calibration of the dot when we replace a valve. So one can understand better. So in the meantime, yes, thank you. So we put back all our cables, and the cables are very easy to handle. Why? Because they are all quick release and nobody can make any mistakes, because the red goes to red, so, and they have a location where to go. The blue goes to the blue, and if we have it, like for example over here we have the yellow, it goes yellow to yellow, and we just connect the pneumatics and another pneumatic over here. So our DST is back on its place. Let's calibrate the DST. So we see how we can calibrate our DST now. So we take the DST, calibrate. So here I'm going to show you the one that I was explaining, doing a teach Z height. So it's a physical touch, okay? And then it will, right now, okay, it's waiting for the heater, the valve, to get this ready temperature for this one. Why do we have a heater? The heater is there actually to make sure that, here that's our dot. That the process remains stable all the time. So our heaters, normally we tell them that define, and it will do a process check. The heater I was explaining, it's there to keep the process on a stable condition. So it is very, very important that we keep this temperature a little bit higher than the ambient temperature. Then it's much easier for you to the process to continue its stability. So as you can see, the machine, after I did the calibration, it checked itself. So it checked itself, so checked the dot for 10 times and confirmed that what I did in my calibration, it optimized it to even make it better. Why? Because on the 01005, every micron, it's a little bit more crucial. So like this, we have shown that our teach, it goes good. So let's see whether now we can dispense. So let's take, because we put the board, we will select, excuse me. Yeah, let's see whether we are able. Yeah. So now we have shown that in few easy steps, the machine is cleaning itself, checking for the dot again, confirming the dot, and starts go for action again. So now we have shown that actually after a valve replacement, it's fast to put machine back in production. And now it's back in production for running for us. One can also do this one for the fluidic replacement, even if sometimes the syringe is getting low. To be faster in production, you just can change the fluidic system. So
Kevin,
I will stop now.
you know, guys, it's like that. If we would continue, most probably in 3 hours, he would still talking about his puma, most favorite animal actually. And it's fast like a puma, isn't it?
Yeah.
Great.
Yes, it's fast.
Thank you very much, Kevin. So I will hand over to our product manager, who will give you a little bit more insight of the technical features of the solution.
Thank you very much, Jürgen. Hello, everybody. So let's go a bit more into a few details. Generally, what is actually the motivation of this process of this solder jet printing? So I'm going to show you now a foil in the PowerPoint where you can see there are many points actually which you could use it for. For example, mainly for cost reduction and time to market. So for example, let's talk about where we, for example, do not have a printer available, or we need to do changes. We don't have stencils available. We have product variants as well, could be a possibility. Other possibilities is, for example, for a repair. And it's not only about missing dots on a process. It could be also, for example, for a fully populated PCB where you need to place new components on it, so you can just put our solution into the product into the machine, jet the needed paste, and place the new component on it. Other nice and interesting things is, for example, the possibility to dispense and to jet into cavities. This is something very special and often needed for special products. Okay, let's go further. The valve itself, this is a so-called DST technology, a dynamic shockwave technology. So the actuator is pneumatic and is a electronically controlled stroke. The heating is integrated within the valve itself and is controlled by our software. And hereby, it's of course depending on the paste we are using, on the process we are using, it is saved in the recipe. The fluidic itself is attached by means of bayonet. Kevin has showed it to you before, that how it looks like. So here we can see that is the yellow part here is the bayonet with the fluidic on it and can be dismantled like this here, you can see on the picture. So with that possibilities, this fast plug-and-play possibility, you are able to change very fast from one paste, from one product to the other one. It's very fast, the change here you can do. We can also dispense and jet, especially many solder pastes from the market. They need to be, of course, jettable. We are working here with AIM, for example, with Indium, Windot, Interflux, and so on. We are getting there more and more new paste, new kind of paste, new mixtures for new products. So this is a part which is actually moving very fast and it's very interesting. The most used types is type 5 and type 6 pastes. They're the more commonly used. We could do also higher types or lower types, but it needs to be jettable, and at the end, don't forget about it, it needs also to be solderable at the end. The dot size can vary with our system from 0.1, 0.5, 0.4 pitch, up to 0.8 millimeter. And in volumes, because we like to talk also about volumes when it comes to soldering, it's about from 2 nanoliters, the smallest one we can jet, up to 60 to 80 nanoliters. Everything is possible with this valve and our system. The compatibility of this VDST is with our newer platforms. Now we're going to be into a bit of the Gerber file import, as Kevin told you and showed you on the machine. What the idea behind this concept, this software concept here, is that we actually use, we simulate a screen printer. Everybody knows how a screen printer means. So for programming that into our software, doing the adaptations is actually quite easy. If you know the process of the screen printer, you can handle it very easy also on our software. The pad filling is automated. With you can also decide what kind of filling strategy you want to have. It's possible to adapt either multiple groups of pads, for example for special component groups or so on, or you can also modify single pads. You can add dots, you can take out dots, you can increase them, you can then smaller, you can do also forms, which maybe don't get from the Gerber file. So with that possibility, you can actually also solder later on very special components, which maybe in a standard it's not that easy. And everything you touch and you change on the in the software, you will see right away in the software screen. Now we're going to talk about some examples we did in the field. Here we have an example of a board with 1,160 components, and if we go a bit more into details, and another product which we did here, for example, to give you an idea what it means to jet print on a PCB, which is, I would say, rather a bit complex, has lots of components. It's rather on the mid-size and high volume components, or solder paste, I would say. So we have here 3,500 dots which we dispensed, and then the dot size were from 400 to 700 microns, and hereby with only one setting it was possible, and changing the parameterization, it was possible to jet this PCB within 6 minutes. Just to give you an idea what it means to jet with our system on this PCB with lots of components on it. Everything what we're doing here, what we are explaining to you, we have of course also on paper. And since there are many solder paste vendors and types on the market, jettable of course, and we have different needs on the PCB side, from maybe from very small components, from 01, 05, 04 pitch, up to 800 microns. We have defined 3 different settings, and with each setting you will have also the combination with the different pastes. So all this has been tested at our house here in our department. So we know what we talk about. We have the statistics a bit. We have the accuracy, we have the volume, the repeatability, and so on. So we have much experience here, and this list is actually growing because there are coming more and more pastes into the market. So you will also get for each solder paste and application process paper, which will be, and these are available so that you have more information about the process. And now just for an overview about our valves. It's a bit repetition here again. What we have are these 5 main valves that you use. It's a time pressure valve. For medium speed, could be rather for medium and high volumes. For medium viscosity, then we have the screw valve. That's the one our Kevin likes the most, because I know why, because it's very versatile. It's not a fast one, but you can really do special stuff with it. You can go also into cavities. You can use it almost for any kind of medium, so the application of it is very, very wide. We have then the volume valve. As the name says, it's rather for larger volumes, which you need to dispense within a short time. Then we have our highest speed piezo jet valve, which we're using for mainly for glue applications. And then the one which we just showed, the VDST, our solder paste jetter for our solder paste, of course. Good. And I will hand you over now, Jürg, again. Thank you very much.
Thank you, Fernando. So I think we have still some people online. I hope you're still with us. Now we want to quick show you 3-4 case studies, and then we will come to an end. Let me show you quick the company Ines, a very small company in Germany, doing their own products, but also products which need a lot of development. So NPI, time to market, is important, but they also have products with larger voluminas. Actually, in this machine you show here, it's our smallest one, the Fox, with dispensing, solder, and pick and place. And this was done when the installation was just finished. Today, this machine has on the left and on the right a loader and unloader, and the CEO you see here is actually running the machine himself. So that's how easy it is. Okay, sorry, I couldn't run it. But he actually goes then to his office. This thing is running completely independent, right? And when something is going on, he has a message on his screen, you know, that he maybe has to refill something or something like that. So that's basically really Industry 4.0 because it's independent. It doesn't need any people around it. We have Roth & Schwarz, which is a rather larger company from Germany, international. We have dispenser in their Czech plant and in Memmingen, close to Munich. And they basically bought the dispenser to learn also for their very complex, huge production, where they can implement this technology. One, for example, they had here, that is a cavity board. So we have 0201 components down here. We have to jet into the cavity and place. And in the middle is basically a bare chip. Cannot tell you for what the product is, but I think it's something up in the sky, or high in the sky. So they do all kind of variation on their machine. And this is a very, very cool example of what you can do in a combination. This is actually, as you see, a very large sheet of foil. The product is basically for walls, ceilings, outside walls on buildings, to have the light, to have video clips, etc. So what we are doing here is the production is that you have a cover plate over the foil in the machine to hold it flat. And so you have cavities where you have to jet into the cavities and place all these LED components. All right, we did that. It was pretty easy. But then Like they came to us and said, okay, we are not finished. You know, you have to place this component. As you maybe can see, I don't know if you see it, it's a rather big component. It's a rather big component. Ah, here it is. Okay, it's actually a board. It's the driver board for this component. So what have we done? We tried actually to place this huge thing with the machine like a component. Very risky because it's heavy and very big. So we changed the production. We said, all right, let's jet and place all the LEDs. Let's jet all the connections, which are a lot down here on the foil. Take the bare board and place it because it's not so heavy, right? Then jet the bare board. It's 0.4 pitch. It's a lot of components on it, right? And then place the component. And then you have a sandwich, so to speak, and you go into the oven. So, of course, this is only possible with a really high advanced jet technology. But it was a very, very cool project, and honest to say, we needed also some process experience together with the customer to finish that. LED, you say LED, that's always a fast production, but on the LED, basically what we are doing here, you know, run LED product in Europe is very difficult. So what actually MAL is doing, right, is also having some specialty, meaning they have 1.8 meter long boards. So if you want to do that, you need a huge printer, but the volumina was not big enough. So what we are doing is basically print only the center part of the board. It goes into the pick and place with the jetter, and the jetter is doing the left side and the right hand side, and then places. The machine is able to handle in steps 1.8 meter. I'm not sure, yes, we have a video. So that's basically, I think it's 1.2 meter, this one here, or 1.5. So it goes to the one side where it's jets. In the middle, it's already printed, right? And then places the respective components. That's artificial, isn't it? Okay, good. And one last one is basically the so-called Essemtec technology. Essemtec technology is basically a foil-based technology. On the bottom, you can see a product example. That's basically in the car. No, I will drive here. Oh, we are now in England, so it will be here, sorry. So English is on the wrong side of the road, right? That's basically where you have the control panel for the lights and for the roof, etc. Now, in conventional technology on the left, you need, I can't read it, but I think it's 25 tools, I don't know how many parts to do it. And with this new technology, which I will show you in a second, it's basically one part, two tools, much lighter, much cheaper to produce. I think we have a video here too. It's basically for car interior. You know, in the future, you see, no steering wheel basically, no knobs anymore. It's all touch, slide, and motion control, motion recognition. And what it does, it brings an intelligent foil to the production. Decoration on it, molded labeling film, print conductive for jet, actually conductive, pick and place, right? And then we have a 2D foil, and then it's a 3D shape in injection molding. And then the product is finished. It's very, very cool. It's a lot of function in this little flat foil. And you can do all kinds of things. You can touch controls, antenna, LEDs, etc., etc. And of course, such a thing you only can produce in one machine with a jetting concept and the pick and place in the same machine. All right, so that's basically it. So wrap it up. Do we want to wrap up first, or you give me questions? Do we have questions on these?
We have questions.
Then come with the questions. Some of you had questions. I'm always getting very nervous in this situation here.
They're not that bad.
Okay.
Where can we get more information about your products? Where do I get help?
Okay, you will not believe, but as a high-tech company, we have a website. Essemtec, www.essemtec.com. Just go in there, have a look. When you have questions, go on the info button, right, and we will get in contact.
Can we dispense solder paste and glue same time on the PCB?
Yeah, we definitely can do this. Some of the people said, but you have then the solder, the oven. How does that work? I'm not a specialist, but when you think about it, one of the big technology what we are doing is matrix headlights. Matrix headlights, right? So the process there is all the same. You print the solder, then you go in the jetter, and then you glue dot every LED. So the LED will then be placed in the glue and in the solder, that it's absolutely not moving, because on the matrix, every move you have in the LED carré will be shown.
Can I use also the new valve for older machines from Essemtec?
No, buy a new one.
What do we do when we have special applications in dispensing?
Yes, actually, I personally love it, because that's the fun part of it, when there is some strange stuff coming around, right? And then I go to Fernando. He is maybe not so keen of it, you know, to get all this special stuff. No, really, we do a lot of specialty. We do a lot of little customization. That is one of our strengths. Be a company here in Switzerland, and we are small, but we are very, very flexible. That's how we survive on this market, right, of this tough market. And by all means, when you have something you think it's something we could do or a good idea, come to us or give it to us, and we have a look on it very fast and can tell you, yes, let's make some application tests.
And there's the last one. Can the smallest dot setting also be used to jet bigger dots?
Yeah, you can. But you maybe will fall asleep. But that's what we basically discussed. When you have a 200 micron dot and you want to fill up with this, a big portion, you shoot dots like crazy. And that's why we have these 3 settings. But some of the customers have maybe a 0.4 pitch, right? But on the other ones, they have, you know, simpler stuff. Industrial electronic. So they have two fluidics, or maybe even 3, and they change it from product runs to product runs.
Thank you.
All right, so wrap it up. Archifis, again, we call it multifunctional center, an all-in-one solution, and a solution you have a lot of flexibility around inside the machine, but also between the models, the platforms. You can use it in a lot of application. It's very clearly, we basically can say, a jetter will be never as fast as a printer, period, right? You have to figure out, or we figure out together with you, what is the best use, a combination, a standalone machine, or maybe it doesn't work at all. But there are a lot of possibilities that you make combinations. We have a lot of different valves, and we have a lot of experience in the processes. I think we just delivered an underfill machine, right, to Germany, and we have applications in Ireland. Aerogen is such a customer, which is medical, has nothing to do with electronic. What we are doing there, it's basically mechanic, etc. So the field is huge, and of course we then have some special application and new technologies. So we have a lot of customers where they pay a pick and place, right? They always integrate one axis for dispensing, because they maybe don't need it, but they see that in the future or sooner future, they will use dispensing, or they need it. Just when they get one component which actually needs some glue, we have to do it somewhere. If you don't have anything on the machine, you have to do it by hand. Good. I think that's it, isn't it? Anything else? Okay, if I would be at the table with you, you could give me an answer. Now you can't, because you are behind the camera. No, thank you so much that you have spent the time with us today, and I hope we gave you some ideas. You got some news, and we hope that we maybe will see you, and you say, that's something interesting. We have to talk to Essemtec or our distributors in your country, in your fields. So have a very good time. Thank you again, and bye-bye. Ooh.